Hello Orissa, welcome to my channel Chemistry Sphere. Today we'll discuss gaseous state chapter and the particular portion is Graham's law of diffusion. Friends, what is diffusion? Diffusion is the property of the gas by virtue of which gas can intermix with another gas irrespective to the law of gravitation. Friends, mainly diffusion means the intermixing of gas without any external agency. That is means the automatical process by which the gases can intermix with each other. Friends, this is your Graham's law of diffusion. Now I will write the statement. Under similar conditions of temperature and pressure the rates of diffusion of gases are inversely proportional to the square root of their vapor densities. Okay. So under similar conditions of temperature and pressure, the rates of diffusion of gases are inversely proportional to the square root of their vapor densities. Friends, suppose this is a container and it is separated into two parts. This is your A part and it is your B part. Both are two compartments, A and B. Here one gas is present. Here another gas is present. Okay. Suppose there is a connection in between A and B compartment. That means with this connection, the gases of A compartment will mix with gases of B compartment. And this process is called as diffusion. That means the intermixing of gases. The intermixing of gases is nothing but only our diffusion. And Graham's law of diffusion statement is under similar conditions of temperature and pressure, the rates of diffusion of gases are inversely proportional to the square root of their vapor densities. Friends, suppose the rate of diffusion of a gas is R1 and it is your R2. The rate of diffusion of gas B is R2 and the density of gas A is D1 and the density of gas B is D2. So R1 and R2 are the rate of diffusion. Friends, rate of diffusion R is equal to volume of the gas, divided by time taken to diffuse. Friends, R is equal to volume of the gas divided by time taken to diffuse. That means R matlab rate of diffusion. Friends, here the rate of diffusion of gas A is R1 and the rate of diffusion of gas B is R2, and D1 and D2 are the densities of gas A and gas B respectively. And by applying Graham's law of diffusion in case of gas A, we will get R1 proportional to 1 by D1 root 2 over. This is your equation 1. And in case of gas B, applying Graham's law of diffusion, R2 proportional to 1 by D2. That is your equation 2. Friends, the rate of diffusion of gases are inversely proportional to the square root of their vapor densities. Friends, if we divide equation 1 and equation 2, we will get R1 by R2, R1 by R2 proportional to, that is your D2 by D1, D2 by D1. Okay, R1 by R2 proportional to D2 by D1 root over. Okay, then we know that molecular mass is equal to 2 into vapor density. We know that molecular mass is equal to 2 into vapor densities. Friends, molecular mass is equal to 2 into vapor densities. Hence, density is equal to molecular mass divided by 2. If D1 is equal to M1 by 2 and D2 is equal to M2 by 2, then putting the value of D1 and D2 in equation 3, we can get here R1 by R2 proportional to or equal to M2 by M1 root over. This is your equation 4. Hence, friends, we can write Graham's law of diffusion. Under similar conditions of temperature and pressure, the rates of diffusion of gases are inversely proportional to the square root of their molecular masses. Friends, Graham's law of diffusion is one of the important gas law, and by this formula, R1 by R2 is equal to D2 by D1 root over and is also equal to M2 by M1 root over. You can also put this formula in various numericals to get the values of different parameters, and you can write final Graham's law of diffusion equation. R1 by R2 is equal to D2 by D1 root over is equal to M2 by M1 root over. This is your final equation of Graham's law of diffusion. Friends, if you have not till subscribed my channel Chemistry Sphere, please subscribe my channel.